Okay, Assalamualaikum and very good morning. Salam sejahtera semua. Hopefully everyone is doing fine during this MCO and still can keep your momentum during these online classes. And we are moving to the last phase of our classes where we have a few weeks before the final exam. So this is the chapter 6 that we're going to discuss with three main topics: firewall system, internet and network security monitoring system, and the last one, digital signature. So the digital signature we're not going to cover, and we're going to discuss it a bit about digital signature, but this one is notes for chapter 6 part 1. We're going to discuss about the firewall. Okay, a firewall is an integrated collection of securities. Okay, is designed to create a boundaries or protection between your public network and your private network. For example, this is a private network, your schools or your universities, and this is the public network where all of the intranet and internet connection that can access to your private network. But before they gain access to your network, they need to be passed through the firewall. Firewall is some sort of filtering all of the information that's going to be coming to your private network. Okay. To protect private networks and individual machines from the dangers of the greater internet, a firewall can be employed to filter incoming or outgoing traffic based on the predefined set of rules called firewall policies. Okay, firewalls, most of the products of the firewalls somehow have the predetermined or pre-installed functionality, where most of the problem that arise during the connection between your private and public network, or maybe you can customize on your own, depend on your firewall policies. For example, if you are some of the organization block Facebook, for example, so anything that have a URL or IP addresses that related to Facebook cannot access to the private network, or this one, the trusted internal network. That means your network. So why they doing this? Because it is a policies. Okay, somehow the untrusted network, okay, being filtered. Maybe they try to harm your system, do the DDoS attack and whatsoever that maybe harm your network, or the policy itself preventing you from accessing the Facebook, for example, or maybe the YouTube. This is somehow maybe going to degrade your internet speed. Maybe the management of the organization think that this is the cause of the performance of the network is poor, because most of the user accessing this streaming media or this spending a lot of time in Facebook. So it's depend on the policy. So during the filtering, there is three things packet need to be filtered with the three outcomes: whether it's accepted, so that means it permitted through the firewall, so there is some wildcard configuration and so on. The drop, not allowed through with no indication of failure, or rejected, not allowed through accompanied by an attempt to inform the source that the packet was rejected. So this is the terminologies. The action is quite similar of the same thing. Okay, policies used by the firewall to handle packet are based on several properties of the packet being inspected, including the protocol used, such as TCP/IP, TCP or UDP, the source and destination or IP addresses, the source and destination of the port, and the applicationable payload of the packet. Example, whether it is contains a virus or not. Okay, with TCP or UDP, there is some signature of the TCP and UDP. Most of the time, TCP header will determine whether this is the incoming source is bad or not. So the source and destination or IP addresses, like I said before, is block, YouTube, Facebook, and so on, and also a destination port. Okay, this is when you use a firewall to identify what port, for example, port 8080 is being blocked. Okay, I know it's 8080 is quite universal and public for the port number, but I just want to give an example here. And the last one, the application level payload of the packet. Okay, somehow they carry the similar packet again and again. Okay, and then it's keep coming. So when it is frequent, so it's going to be blocked. So it's depend on your configuration. So the blacklist and the whitelist, okay, the blacklist approach, all packets are allowed through except those that fit the rules defined by the specifically in a blacklist. So blacklist, you need to somehow upload to the firewall system or firewall application by using text or any command or any file that going to filter all of these things. I know this is going to consume network traffic, but it is good in the long term. So the advantage of this is flexible in ensuring that service to the internal network is not disrupted by the firewall. But the drawback of this is unexpected form of malicious traffic could go through. Okay, most of these things have a bad thing and a good thing. So this is the problem with the blacklist. So the whitelist approach, we call it a default deny. So packets are dropped or rejected unless they are specifically allowed by the firewall. The advantage is a safer approach to defining a firewall rule set, and the drawback or the disadvantage is must consider all possible legitimate traffic in rule set. So it's up to you to identify or to filter all of these things. Okay, back to back it is based on this. See, the firewall policies. Okay, you as an organizer, experts in security, you need to advise your, for example, in UTHM we have a Pusat Teknologi Maklumat, the Information Technology Center, where all of the incoming network being filtered by this department or this center based on the policies that being identified by the top management. Okay, and this thing can be changed regularly because the attacking or the untrusted source of the internet comes and go and keep dynamically change. Okay, we have a few firewall types. We have a packet filter. We call it a stateless. Why? Because it's stateless. If a packet match the packet filter set of rules, the packet filter will drop or accept it. Okay, it's very straightforward. Okay, for example, IP address this, okay, it's been blocked, so it's not allowed. So as long as the TCP that carry all of this information will block by the firewall. We call it as a packet filter. The stateful filters, however, it maintains a record of all connection passing through it and can determine if a packet is either the start of a new connection, a part of an existing connection, or is invalid packet. So this is the stateful. What is different between this stateless is the firewall itself try to determine whether the packet is either a new connection or not, or whether it is invalid or not, a valid packet or a not valid packet. So it need to be filtered first before it pass through the filters in the firewall. So this is we call a stateful, where all of the packet need to be identified first or filtered first before it go through. It's different with the stateless, where if it meets the rules, okay, it is blocked. So the last one, the next firewall type, we call it application layer. So it works like a proxy. It can understand certain application and protocol. It may inspect the contents of the traffic, blocking what it views as inappropriate content. For example, website viruses, vulnerabilities, and everything. That is why the listing, the wildcard of the prospect untrusted coming traffic can be filtered by this application layer. Okay, so this is the explanation of the stateless firewall. Like I said before, okay, it's depend on the condition that you set up in your firewall before it go to the to your private network or anything that you send back to the public network. Okay, stateless firewalls may have to be fairly restrictive in order to prevent most attack. Restrictive mean, for example, this one is allow outbound sync packet destination port 80, and then it's drop inbound sync packet and allow inbound sync another packet source port 80. So this is happen when this blocking, okay, this blocking is a predefined or means being set up by the firewall policies. Okay, stateful firewalls can tell when packets are part of the legitimate session originating within a trusted network. Stateful firewalls maintain tables containing information on each active connection, including the IP address, port, and sequence numbers of packet. So using this table, stateful firewalls can allow only inbound TCP/IP packets that are in response to a connection initiated from within the internal network. Okay, from this explanation, okay, we add this, the firewall stat table where it stores the TCP session. Okay, the TCP session will be interpreted by the firewall. Okay, whether it is okay, let's see the step by step. Okay, you request something from server. Okay, the server address is this one, 76.120.54.101, and then it's reply. Okay, and then it's sent back to the server, and then the attacker try to respond back to the client, but it's been blocked because of this. The session is being identified as a blocking for the firewall. Okay, TCP based connection are easy to check, and UDP based traffic connection is not so clear. So what is the difference between these two? And when you learn data communication concept or DCC, okay, we have this type of packet. We call it a TCP and UDP protocol. Most of the TCP header is the head of information that being carried in the packet. UDP most of the time is the content of the packet. So all of these things, it's easy to identify for the TCP because it's smaller in size and normally it's carried header information. But UDP is the content. It's very hard to identify what is inside the UDP packet itself. And then the size of UDP is quite bigger instead of TCP. So in the form of data packet, TCP considered as a header and UDP is considered as a container. So most of the content that being carried out by the packet is content of these two. So that is the problem when we are try to identify whether this is a legitimate or not legitimate content of the packet. Okay. Okay, firewall on Windows and Linux. Okay, you can set this firewalls on Windows and Linux. How you want to do this? Actually, we try to block. Anything that you think it is harm to your network. Okay, for example, if you want to filter YouTube, so any information that carry for YouTube is being blocked, so you cannot access, even though the connection is there, but you cannot see the content or it's being blocked. Okay, you can ping the website and then but you cannot see the content. It depends on your setup of the firewall. Okay, that's it for firewall. Okay, we call it now we are going to discuss tunneling. Okay, this is the tunneling. Okay, the tunneling is the process where we want to establish some sort of a private network by using public network. Okay, for example, the easiest example is how we want to integrate or communicate between UTHM Parit Raja and UTHM Pagoh through a tunneling. So that means you are actually using a public network, but the environment is same like a private network. So that means even though you are a distant away from UTHM Pagoh, but you have this communication like one network in UTHM as a whole. So in these two, okay, we going to pass or sending or receiving information through the tunneling. So the tunneling itself have this encryption and decryption process where the same network can identify. So that means anything that you send, it being encrypted and passed through the public network and then decrypted back and moved to the private network. Okay, for example, you want to send something to the network in UTHM Pagoh. Okay, you send as usual, even though it takes a lot of time because of the distance or obstacle during the transaction process through the public network, but the environment is still the same. So the tunneling process is the process of encrypted and decrypted information between two distance of network, but can be act as a same network. So that is the tunneling. So the advantage of this tunneling is it prevents eavesdropping. So eavesdropping, it means that if someone try to tap your network and tap your network by eyeing or stealing the packet that transferred between those two destination of the network, so it being decrypted. So that is it being encrypted and decrypted. Only the policies, only the application that manage the tunneling will know the process of encryption and decryption. Okay, the next one is SSH. Okay, SSH stands for secure shell. Okay, the client connects to the server via a TCP session. The client and server exchange information and administrative details such as supported encrypted method and anything blah blah blah. Okay, the client and server initiate a secret key exchange to establish a shared secret session key, which is used to encrypt their communication but not for authentication. So this session key is used in conjunction with the chosen block cipher, typically AES, 3DES. So this is for security student. This cipher block that can be encrypted and decrypted. In other words, okay, we're going to use this secure shell to establish communication between one node to another. Most of the time is from one PC to another PC, or most of the time from one PC to the server. Okay, the reason this because the packet that you transfer between your front end interface, okay, that will share the secret key in exchange, so that only both nodes can understand. Okay, I know if you are hackers and you can try to run false decrypted, okay, it can be done, but it's try to prevent this information. So anything that you get between this secure shell communication between nodes to nodes, it's hard to decrypt it. Okay, a secure interactive common shell. You can try this. Okay, you can try this by looking to establish communication, user log into the web server or any server from one network to another network through this SSH. So what is the IPsec? Okay, IPsec defined as a set of protocols to provide confidentiality and authenticity for IP packet. It content of authentication header and it encapsulating security payload. In other words, it's a protocol that have these two things, AH and ESP. It's provide connectionless integrity and data origin authentication for IP datagram. They provide protection against replay attacks. No confidentiality. Packets are still unencrypted. When you use this IPsec protocol, you try to protect all of the data, all of the packet that being transmitted. Okay, for that means if you want to send something, okay, for example, email, okay, login authentication process, okay, most of that is being protected by the IPsec. It's actually a group of protocol that can handle the confidentiality and authenticity for the IP packet. Okay, the last one is the digital signature. Okay, we have this this packet, the content of IP header, authorization header, and a payload. Payload normally is a data. Before all of this packet is sent to another nodes or another location, okay, all of these things need to be sent and carried, and we have this authentication data. So all of this authentication data is considered as a digital signature.